In this video we will see that how to draw shear force and bending moment diagram for specifically cantilever beam. Say there is a cantilever beam. So the cantilever beam has a UDL here and a UVL here. Say this is 10 kilonewton. Say this value is say 20 kilonewton per meter. Now the span here, if it's A, this is B, C, this is D. Now this span this is say 1 meter, this is say 1 meter, this is say 0.5 meter. Now to before starting this problem, we can summarize our previous concepts. Please note down this thing that if a table we make, if this is a loading, this is SFD profile and this is BMD profile. So if the loading is point load, SFD profile will be linear, BMD profile will be linear. If the loading is UDL, BMD profile will be linear, SFD profile will be linear, BMD profile will be parabolic. And if the loading condition is like UVL, this is UDL, this is point load, then SFD profile will be parabolic and BMD profile will be cubic. So remember this thing, it will help you to solve this problem very easily. Now before going to this problem, we can this may be looking very complex thing, but this is, if we simplify this problem, this can be simplified as, say this point is D, this is A, this point is C and this is B. So here one point load of 10 kilonewton, here UVL is there, and this is nothing but a UDL part, that is also 20 kilonewton per meter, and this is 1 meter, this is 1 meter, this is 0.5 meter. Now we can solve this problem. Now first we need to find out what is the reaction developing here. Now this is RA. To find out the reaction, first write summation Fy is equal to 0, upward positive. Now RA is upward. Find out all the downward forces. This is 10 kilonewton, that means minus 10. This UVL is in downward direction, that means minus. Total load means this area, that is half into ordinate, means this value is 20 kilonewton per meter, and total distance is 1 meter, and minus this UDL. So it has also a load intensity of 20 into multiplied by this distance, that is 1, that is equal to 0. That means RA is equal to 10 plus, this gets cancelled, 10 plus 20, that means 40 kilonewton. We have found out the value of RA at point A. Now we will find out what will be the shear force and what will be the bending moment. Now from right to left, first consider the point, so SF at B. Now as B has a point load, so we'll have two value, one will be just right and one will be just left. So just right of B, there will be no effect of load, that means the value will be 0 kilonewton, and just left of this B point the whole effect will be considered, that means 10 kilonewton, but as it is acting in downward direction, that means the value will be minus 10 kilonewton and magnitude will be minus. Now consider this point C, SF at C. There is no point load, so there will be only one value, and at point C there is no effect of this UVL, only this 10 kilonewton is there, that means minus 10 kilonewton will be there, because we have to consider only the right side of that point. We will go from right to left. Now consider SF at D. Right of D has 10 kilonewton and UVL. So minus 10 kilonewton is there. UVL is acting in downward direction, that means minus. So total load will be minus half into this ordinate 20 into this distance, that is 1. That means minus 10 minus 10, that is minus 20 kilonewton. Now we have found out at point D. Now point A, SF at A. So A has a point load, so we'll have two value, one value at just right, one value at just left. So just right of point A, all those load are acting here. So previously minus 20 kilonewton is there, so along with this minus 20 means the effect of 10 and this UVL, and A consists of this UDL also, so this value will be add up with that value. So this is downward, that means minus into total load. Total load means this intensity into distance, that is intensity 20 multiplied by this distance, that is 1, that means minus 40 kilonewton. Now just left value will add up this RA value. So minus 40 will add with this RA, as RA is upward acting, that means that will be plus. So 40 plus, we have got 40 here, that means 0, that means our calculation is absolutely correct. Now we'll draw the shear force diagram. So draw the dotted line from every single point of consideration. So draw an ordinate. Now at point B there is two value, one first 0 then minus 10, so first 0 then minus 10. Then SF at C, C has a value of minus 10, D has a value of minus 20, A has a two value, one is 40, another is 0, that means 20, then that is 40, and this is 0. Now add up all those values, 0, 10. Now this is point load, so this will be linear. This is UVL. So for SFD we have UVL value, UVL profile of parabolic. So what will be the nature of this parabola, that is increasing in slope or decreasing in slope? Check out the value of check out the value of that load intensity, whether it is decreasing or increasing. Here this is 0, here this is 20, so this is going increasing, that means the slope will be also increasing, that means the parabola has a increasing slope. Then there is a UDL, so UDL means SFD profile will be linear, that means these have a linear profile. So this is negative, this is shear force diagram. So we can check, this is linear, this is parabolic, and this is also linear with zero slope. Now we will start with bending moment calculation. So I am removing this part. Now here we have 4 points, so we have 4 bending moment value: BM at B, BM at C, BM at D, and BM at A. So where the moment will be maximum, because this is a cantilever beam, so the maximum moment will be generated in the support only, because this is fixed support and this support will try to resist all this loading subjected to this beam. So here only the maximum moment generated. So we can easily find out that the value will be bending moment at A will be maximum among these 4 values. So at B, as there is only a point load, but the load is acting on this point itself, there is no distance here. So BMB will be 0 kilonewton meter. Now at C, just right side of the C, there is only 10 kilonewton which is acting downward. That means it has a tendency to rotate in clockwise direction. That means our bending moment consideration is negative, clockwise negative. So minus load, that means 10 into distance, that is 0.5, that means minus 5 kilonewton meter. Now at D, D has right side of D there is point load and UVL. So we have to consider this 10 kilonewton and this UVL. So both these load are acting in downward direction and have a tendency to rotate in clockwise direction. That means first we will consider 10, that is minus, as this is rotating in clockwise direction, 10 multiplied by distance. So what will be the distance? So we are considering this BM at D, so we have to consider this point D to find out the distance. So 10 kilonewton has a distance from D of 1 plus 0.5, that is 1.5 meter. Now this UVL, this is also minus, that is it's rotating in clockwise direction, and total distance, sorry, total load, that is half into this 20 into 1, this is load multiplied by distance. Which distance? The distance from D, the CG distance. That means this is a, if this is a base, that consideration, that means this will be 1 by 3 meter, that means into 1 by 3. So this will be minus 15 minus 10 by 3. If we calculate this, we have minus 18.33 kilonewton meter. So at A, now we'll consider point A. So A, after right side of the A, all those loads are acting. So first we'll consider 10 kilonewton. So the distance from A is 1 plus 1 plus 0.5, that means minus, as it is rotating clockwise direction, that means 10 into distance, that is 2.5 meter. Then UVL total load means minus half into 20 into 1, this is total load multiplied by distance. Which distance? This CG distance from A. So A to D is 1 meter plus this 1/3 value, so 1 plus 1 by 3, and the consideration of UDL. So this is also acting in clockwise direction, so minus the load, total load means 20 is the intensity multiplied by this distance, that is 1, this is a load multiplied by distance. So what distance? The distance from A, the CG distance. So UDL acts, the CG of this UDL acts in the center of this span, so this is 0.5 meter, so multiplied by 0.5. So we get a value of, say, minus 25 minus 10 into 4 by 3 minus 10 minus 10. So here we get plus 35, here we get minus 48.33 kilonewton meter. So you can check that we have the maximum bending moment value at A. So if we draw the profile, we get at B this is 0, at C this is minus 5, at D that is 18.33, and at A this is sum of 48.33. Now the profile will be in bending moment, as this is point load, that means here this will be linear, this is UVL C to D, SFD is parabolic, BMD will be cubic. As SF value is increasing, bending moment diagram slope will be also increasing in nature, that means the slope will be like this. And then this is UDL, that means SFD is linear, this will be parabolic, so we will have the value somewhere here, so we will get like this. So this is negative and this is the bending moment diagram. So in this way we can find out in a very short time. So if you want to practice some more questions about this cantilever beam, these are some questions, the link are given in the description box. If you have any doubt or if you want to get the answers of these questions, mail me at this mail ID. So if you like this video, don't forget to hit the like button, and if you are new to this channel, don't forget to subscribe. Thank you for watching.